There are software systems where an end user can interact with it through a language. That is, the user can write scripts, macros, or rules that access and compose the basic features of the system in new ways. Let's take a look at this formula for the Microsoft Excel spreadsheet application. This simple formula is asking Excel to sum the values in cells A1 to A4. Excel is able to do this at runtime, and this functionality is not limited to just cells A1 to A4. The application is able to carry out the intended calculation because it is able to interpret the formula into an intermediate representation, and then execute this representation. Built into Excel is a component called an interpreter that has this responsibility. In fact, the end user doesn't need to know about the underlying implementation of the function. They don't even need to know about how the formula or the spreadsheet is represented. The interpreter takes care of properly handling the requested calculation. In addition to enabling programmable applications, systems based on interpreters can allow an end user to write scripts, macros, or rules that access, compose, and run the basic features of those systems in new and dynamic ways. The interpreter-based architecture is used in a variety of commercial systems because it provides users with flexible and portable functionality. Interpreters can be used to run scripts and macros. Systems can use an interpreter to drive programmable actions specified by the user. Scripts are often used for automating common tasks. For example, users can write scripts to schedule tasks, performing repetitive actions, and compose complex tasks that invoke other commands. Macros are an evolution of scripts, and became popular with the introduction of graphical user interfaces. A macro records keyboard and mouse inputs so that they can be executed later. This allows users to record interactions with the user interface, which may be either repetitive or complex, and then replay the recorded actions in a simple and quick way. An interpreter allows you to add functionality to a system, or extend existing functionality of a system. This is done by composing pre-existing functions together in a specific sequence in order to create something new. These pre-existing functions are defined by the system architecture and offered to the user. The developer thus avoids the need to implement all possible combinations of functionality. For example, a web browser extension, not a plugin, is a component that adds new functionality to the browser and can customize the pages that the browser renders. Such a component is typically implemented in a language like JavaScript, to be run by an interpreter embedded in the browser. Having a system with a built-in interpreter is not only beneficial to developers, it encourages end users to implement their own customizations. Toward this end, a system can offer an easier-to-use language that has domain-specific abstractions suited to the needs and thinking of the end users. This is an advance over requiring end users to use the general programming languages that professional software developers use. Besides building an interpreter into a system, the system itself can be implemented in a language that runs upon an interpreter. This can make your system more portable, so it can work on platforms that the interpreter supports. The interpreter and its environment essentially abstracts the underlying platforms, so your system can be more platform independent. Portability is becoming more important with the rise of virtual machines and virtual environments. With more services being hosted in the cloud, it is becoming increasingly important to be able to develop and deploy software systems onto hardware that you have no control over. However, interpreters can be slow. Basic implementations spend little time analyzing the source code and use a line-by-line translate and execute strategy. This is a classic trade-off. It may be faster and more flexible for developers to use an interpreted language, but slower for the computer to execute it. Let's take a look at an example of where interpreters are used for Java programs. Java programs are first translated into an intermediate language that is loaded into a JVM, short for Java Virtual Machine, which then executes the intermediate language. The JVM will attempt to optimize the intermediate instructions by monitoring the frequency at which instructions are executed. The instructions that are executed frequently get translated into machine code and executed immediately. On the next execution of the same intermediate instructions, the JVM uses lazy linking to point the program to the previous machine code translation. Instructions that are not used frequently are left for the interpreter of the JVM to execute. This decreases execution time, since frequently used instructions do not need to be constantly translated, and the entire program does not need to be translated all at once. The JVM also provides portability to Java programs, allowing them to run on many operating environments. Interpreters support many different uses, such as scripting, creation of macros, and enabling programs to work across different computer architectures. As a designer, it's important that you understand the role of interpreters in a system's architecture, as they can be used to address needs for programmability, flexibility, and portability.